Hello, welcome to ECE 492. And in previous chapter, we learned a very fundamental neural network, and that is the single neural network, which means in that one we have a single neuron, and we have a multiple input and a single output. That also called the linear perceptron. And in this chapter, we are going to introduce a more complicated and more powerful neural network. That is the multiple layer neural network, or you can call that one as the multi-layer perceptrons. Let's start from the motivation. So in previous chapter, we learned the single layer perceptron. So that can handle the problem of linear separable classification problem. We know here we have two classes, class 1 and class 2. So according to these two classes, we can draw a straight line that's called the decision boundary. So one class is on one side of the boundary, another class on another side. So we call this one as the single layer perceptron, or we can call that one as a multiple input, single output neural network. So in last class or last chapter, we learned how can we construct the single layer perceptron. That including the weight and the input, the output, the activation function. So that is how do we construct the single layer perceptron. And we also use a computer project to apply this single layer perceptron to solve this linear separable classification problem. And just like here, this is the single layer perceptron. Here we have two input, x1 and x2. They are the coordinate of each pixel. And here we have extra input 1. That one can work as the bias. And W0, W1, and W2, they are the synaptic weight. So for this neural network, we know we have the x1, x1, x2, then multiply with their weight, and then sum together. We get the V, and V as the input of the activation function, phi, and then we get the output. And here, the optimum weight for W0, W1, W2, that's called the optimal synaptic weight. So we learned how to adjust all this weight, start from a random setting until reach their optimal value. We learned two different approach. One is very straightforward, just to find the simplest way to find the weight. The second one is for your project, you use the Newton-Gaussian method to find the weight. So why do we need a multi-layer perceptron? So here is the problem, here's the issue. We have two classes. Again, we try to solve the same problem. We have x1 and x2. So, but these two classes not linearly separable. For example, you never can really draw a line to separate these two classes. So no matter how do you draw the line, there are always some parties misclassified, which means a single layer perceptron cannot handle such issue. We need a more complicated and more powerful neural network. That is the multi-layer neural network. So be more specific is multiple layers, multiple inputs, sometimes multiple outputs. So that can be used in the nonlinear pattern classification problem. That is the focus of this class. So here's the goal of this section. The first is understand the basic structure of multi-layer perceptron. And then we need to understand the popular multi-layer perceptron training approach. That is the back propagation algorithm. So the back propagation algorithm is the most important factor in the multi-layer perceptron. So we need to spend a lot of time to understand how can we apply the back propagation algorithm to train the multi-layer perceptrons. So also we should be able to apply the back propagation algorithm in the multi-layer perceptron training. So here's training. Training means we need to train few things. One is how do we set the weight? So basically it's the tree, how the weight, the synaptic weight. And then here, there's something we need to put into the consideration. For example, how many neurons we need, how many layers we need, and what is the activation function we are going to choose. So all these factors is also important, and we need to consider this during this chapter. And the last one is understand and be able to apply the convolution neural network in the solution of difficult pattern recognition. So here is we use the CNN, convolution neural network. So I bet you guys heard this name a lot. The CNN is a very powerful um, tool to in the image processing, computer vision, a lot of applications. So, but the in general, the CNN is one of the multi-layer perceptron, or you can see the CNN is one of the application of a multi-layer neural network. So we were going to introduce the convolution neural network in this chapter and also give you guys a very interesting project. So the basic features of a multi-layer perceptron including the following stuff. The first is the model of each neuron in the network includes a nonlinear activation function, and that is differentiable. So here is nonlinear. In previous chapter, we kind of know the activation function, but we didn't really use that because we are set there are linear activation function. But in this chapter, we will apply the nonlinear activation function in the neural network. So one of the important feature about the activation function is that one must be differentiable. Okay, so next topic is the network contains one or more layers that are hidden from both the input and output nodes. So that could be the neurons. So here is for the hidden layer. There normally could be between one or more layers. So you can see you have more layers. The problem, your neural network is potential is more powerful, but its potential is more complicated. So that's sometimes you need a balance of your robust and your accuracy of your neural network. That means you want to set how many layers for your multi-layer neural network. The more layers, the computation cost is more expensive, but should be more powerful and more accurate. So the third items is the network exhibits a high degree of connectivity, the extent of which is determined by synaptic weight of the network. So here's high degree of connectivity. It means for different layers, from one neuron to another one, they could have multiple connections. So we will learn this later in more details. Okay, here is the very fundamental structure of the neural network. Okay, we will let you guys to know this more details in next video. But here you can see you have input, you have a hidden layer, and you have the output layer. It's much, much more complicated compared to the single layer perceptron. All right. So in next chapter, in next video, we will go details for each component of the multi-layer perceptron.